So this is a small presentation on sinusoidal waveforms. So the basics of sinusoidal waveforms are they are curves that describe smooth repetitive oscillations. All waves can be made from adding sine waves. This here is just the equation for sinusoidal signals, and the three characteristics that separate sinusoids are amplitude, frequency, and phase. And this picture is just an example of a sine wave. So the equation written here for sinusoidal signals: T represents the period, A represents the amplitude, omega represents the angular frequency, which is 2 pi f, and phi represents the phase constant. So the period pictured here in the graph is the distance from one peak to another, or can be described as the length of one cycle. The natural period of sine is 2 pi, but the actual period is b times 2 pi. So b is the coefficient of 2 pi. As b decreases, the period increases, and as b increases, the period gets smaller. The amplitude is the height of the sine wave. It's A in the equation for sinusoidal waveforms. The bigger A is, the higher the amplitude on the waveform is. And these are just, this is an example of a modified amplitude shown below. So the amplitude here is, will be 3, and here it's doubled to be 6. The frequency is the number of complete cycles per second. So it's 1 over the period, and it's measured in hertz. When the period increases, the frequency decreases. You can find that from the 1 over the period there. And if you want to change the frequency, you would change the f value in omega equals 2 pi f, which is this is what omega equals 2 pi f, and that would change the frequency. So here's just an example of a modified frequency. Again, it's doubled. The phase refers to the horizontal position of a waveform with respect to one cycle. Phase shift is the shifting of the signal horizontally. It's represented by phi in the sinusoid equation, and the addition of phi shifts the phase to the right and the subtractance to the left. And once again, this is a modified phase here, so this is phase shifted on the right, and this is the original sine wave. So that's all. Thanks for listening.